Okay, so we have OC is 5.3 centimeters. Okay, how can you find now the line segment CD from here up to here? Alright, we know that from O to D is our radius, and we know the length of our radius. So the radius is 8. So to get the CD, all you need to do is CD is equal to the radius. I'm just going to put the radius first, minus this OC here, or the A. So we subtract the OC. So the radius, we know it's 8, 8, and 8. So we have 8 cm minus the 5.3 cm. So our CD is now equal to 2.7 centimeters. Alright class, that is I think for grade 7. But to get the central angle, it's much more complicated if you do not know the SOHCAHTOA. And for the advanced learners, they are not going to use the SOHCAHTOA anymore. They will use the law of cosines. So let us find the angle now by using the SOHCAHTOA. Okay, I'm going to erase this one. We are done with the easy part. Now we have the harder part now, which is for advanced learners, or maybe in grade 10. If you don't have any background or SOHCAHTOA, then this one is very hard. We don't understand anything here. Alright, let's have this triangle again. So I'm going to draw this triangle here again. Okay, and this one is 90. This one is 6, the even, and this one is 8, the hypotenuse here. And we are going to get this angle, which is half. It's half only of the central angle, because the central angle or the subtended angle is from here there. The whole thing there is our measure of our AB or central angle, and we are doing only this part here, finding the theta, and is the theta here is actually half of the central angle. So what is this triangle? This is triangle O and C and A. So triangle AOC, COA, whatever. So here is our reference angle. What kind of side is one from the theta? Here, it is the opposite. Okay, that's the opposite. And what kind of side is that? The 8 from the theta. It's because this one is the right angle. That one is the hypotenuse, HYP. So what kind of functions are we going to use so that we can have the opposite and the hypotenuse? So based from our SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Now we have the 3 basic now. You don't want the inverse because it's very hard to press that one in the calculator. Unlike sine, cosine, tangent, we can easily find that one in our calculator. So here we have the opposite and the hypotenuse. So here there's only one function that has opposite and hypotenuse, and that is the sine. So we are going to use the sine. So here we have sine of that angle theta, which is half of the central angle, is equal to the opposite. What is the opposite? 6. This one is 6, and the hypotenuse is 8. Then we divided 6 over 8 is actually 3/4, and 3/4 is 0.75. Then you put like this, and you will see that they are going to write like that one. Arc sine is sine -1, and then 0.75. And then theta, how are you going to press that one in your calculator? You press that one in your calculator by pressing the shift and then the sine and then 0.75 and then equals. Okay, and then when you do that one, and you will have the theta is 48. Let's have our answer to the tenths of our degrees. So 48.6 degrees. That is the theta. So if that one is half, how much is the central angle? So the central angle, which is also like this, A to B, that angle is obtended by arc AB. So I'm going to put AB here, like symbol. Okay, AB, and an arc here is 48.6 times 2 here. So the central angle is now equal to 97.2 degrees. That is the measure of our whole central angle there, 97.2. This one is theta. So we have another theta there. So 2 times the theta gives you 97.2 degrees. Okay, let's have the solution of the more advanced learners, those who are maybe doing the pre-calculus. So they know already the law of cosines. So for the law of cosines, we have A, B, and C. This is always plus. It's not like the Pythagorean theorem that when you are solving for A, it's C minus. If you are solving for B, it's C minus A. So it's not like that. If this one is A, then you have BC. If this one is B, then you have A plus C. Both square, they are always square. If you are solving for C, then it's equal to A here and B there. It's like the Pythagorean theorem if you are solving for C. If you are solving for A or B, it's not Pythagorean anymore because this is always plus. So if you have A here, there is the angle, there is the side. We have the 3 sides. And that one is A, this one is capital letter A, angle A. If this one is B, this one is angle B. If this one is C, that one is angle C. They are opposite. Means they are opposite. There's A here and the A here. And then minus is always minus. And you have the 2 here. And whatever letters here will be the letters here. It's 2 times B times C and then times cosine A. Or if you look at here without memorizing the formula for law of cosines, these 2 sides here are the 2, what you call that, sides that are keeping the angle here, the included angle in between. So if you want to solve this one, you need this side and this side, the 2 touching sides. They have this one. So in this case, where are the 2 touching sides? We have the 8 and the 8 because that one is touching and angle alpha is here. Okay. So whatever is touching here will be your BC here. If you have AC, then you have AC. And then you have this one. Okay, we don't memorize the formula. All you need to do is just remember and how to use the formula. Okay, we don't care about the letters now. Okay, we are solving for the alpha. We start with the side because there's 3 sides. Opposite of the alpha, which is the central angle, is the 12. So we write here the 12. It's 12 here. And don't forget the square. It's a square. Okay, we don't care about the letters anymore. It's equal to the 2 touching sides here, which is 8 and 8. These 2 are the radii here. Radius. So we have 8 here, 1 is 8 here, square, plus the 8 there, they are both 8, square. Then minus, the 2 is always there. We multiply this 2 by the first one, 8, and by the second one, which is also 8, and then times the cosine of the opposite of the 12 centimeter side, which is the alpha. So we have the central angle alpha. Now we have that formula. All we need to do is just compute. So we have 12 times 12 is 144. This one is 8 times 8 is 64. Plus this one is 8 times 8, 64 minus 2 times 64 is 128. 8 times 8, 64 times 2 is 128 cosine alpha. This one is our known. Okay, we add 144 is equal to 64 plus 64 is 128 minus 128 cosine alpha. Do not subtract 128 and 128 because the 128 here should be multiplied by the cosine alpha, which we do not know yet. Okay, we transpose negative 128 cosine alpha to the other side and transpose 144 to the other side. So this one, the whole thing here will be positive now. Is 128 cosine alpha is equal to, this is 128, and this one will become negative on the other side, 144, and then when we solve for that one, it's 128 cosine of alpha will give us a negative because 144 is greater than 128, and it will give us negative 16. We remove the 128, so we divide this by 128. We also divide this by 128. Okay, I'm going to erase this one because we don't need that one, and also the title here. So it will not be having space here. Here, I'm going to write here. So here we have cosine alpha is equal to, if we divide 16 by 28, it will give us negative 0.125. And then to solve for alpha is just like the same as the first solution. We have cosine negative 1 enclosed in parentheses. Don't forget the negative 125 here. And alpha, again, you press the shift or the inverse of the second F, and then cosine, and you will see that the display will turn into cosine negative 1. And then you press minus. You have also the minus, you change the sign. And then 0.125, and press enter, and your central angle now is directly the same as our first solution, which is 97.2 degrees. This one is for the advanced learners. I think this one is not recommended for the grade 7. For grade 10, grade 11, they can use this one. They can use the Pythagorean theorem, the trigonometric functions, the SOHCAHTOA. But for the Pythagorean theorem, I think the grade 7 can use that one. Okay, thank you learners, and see you.